We're at Go To Math, working some calculus, looking at continuity and one-sided limits. And we are in that section right there. And what's going on here? What do we do? Why do I have the answer already here? I don't know. Let's go to the whiteboard and let me rewrite this out. Find out what's going on there. Ooh, we need to clean that. And let's use some blue ink this time. Looks like a color there, dark. How about lighter? How about that color? That looks like I like this color. F of x. I may use this color in the rest of the section. We got the big curly brace, bracket, whatever you want to call it. 37, it is the curly one. X is less than or equal to 7. And then we have AX plus 9. Do we even know what we're doing here? What was the question? I should have probably wrote it out. Alright, we want to find an A such that it makes f of x continuous on the entire real number line. But here's the deal. We know that this function here, f of x equal to 37, right? That's just a constant. We know that's totally continuous. F of x equal to ax plus 9. We know that this is going to be continuous on the entire real number line, as long as a is a real number, of course. But the question is, what about when they're joined, where they're joined? And that is the question here at 7. So if we were to look at that definition of continuity, first thing we're going to test is, right, we're going to test at f of 7. I'm going to do this time without drawing a graph because it's just a whole lot faster. Plus, it's probably something that you should need to know how to do without looking at a picture. We plug in 7, and that means we're going to be using this one up here because this says we include 7, right? So when we plug 7 in, we get 37 out. So for every value less than or equal to 7, you're going to get 37 out. Alright, then the next thing we have to test, of course, 7 is what we're interested in, and this would be this part of the function, ax plus 9. Alright, now remember that both of these must be equal to each other, and if they are, then we could say that this thing is continuous, really continuous at x equals 7, but it's also continuous everywhere else. What we can do here is just do direct substitution, plugging 7 directly in to find this limit, but we still don't know what a is. But that's okay. In order for this now to be continuous, f of x to be continuous, these two numbers here must be equal to each other, and that means that we're going to set them equal to each other and solve for a. So we have, solving for a, we'd have 37 minus 9, taking the 9 over to the left makes it a minus 9, and alright, and so let's see, 37 minus 9 is 28, right? Have I got that right? And whoops, that's supposed to be an a there, it's morphing into other things. And then of course we'd have 28 divided by 7, and therefore a must be equal to 4. Okay, so it's that simple. That's all you got to do. Just set them equal and solve for a, and psh, there it is, right? And so we could say now that a, we could replace this a with a 4. I'm just going to kind of write it in here, and there it is. It's now continuous. I believe that's the reason why we got a 4 here. Alright, so you go to this section, find this problem, click, 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 and you practice that. Alright?